So please start applauding for Fotis coming on stage. While Fotis gets ready, a funny story. I was telling him he's from Greece, even though he lives abroad. I was telling him that my favorite island from Greece is Mykonos. I was really hyped up about it, and he's like, yeah, but I'm from Crete. So yeah. Please, let's give him another round of applause and let's listen to his talk.
Thank you. Thanks a lot for inviting me, by the way. It's always a pleasure to be in Italy, even though I eat way too much every time. My name is Fotis. I'm from Greece, from Crete. And Crete, by the way, it's way better than Mykonos. But I'm living in Barcelona for the last 18 months. I'm building websites since 2010, which is not a long time, but in front-end years, it is an eternity. The coolest thing back then was jQuery, to have some perspective, and a bit later Backbone.js. I have started in a small, tiny startup as a first engineer, but for the last 7 years, I'm working on big or very big companies. And the code base and the ways of working are way, way different. It's not just more code, it's the way you write your code, the architecture, the way we interact with other engineers. Everything is better. I have seen some things that work and many things that don't, and that's why I'm here today to talk to you about large-scale Nuxt architecture. Let's start with Nuxt. My first impression that Nuxt is used for server-side rendering. And it's true, it made things a lot easier by abstracting a lot of complexity away. But Nuxt does way more than that. It is a very opinionated framework built on top of Vue. It takes a lot of decisions for you and establishes many standards and guidelines, which are very important when you have a lot of people working on the same code bases. Some of those features are file-based routing, automatic component discovery, no web app configuration, built-in ICO, smart prefetching, critical CSS, and Nuxt image. You get all of this for free without any effort. You could implement it in a Vue project, but having a well-tested way of doing this, it's always welcomed. And let's also try to define large-scale architecture. It's not a clear term. There are multiple definitions around the web. Some about number of users, number of developers, numbers of lines of code. But the widely accepted definition is that large scale is programming by large groups of people or by small groups of people over longer time periods. Either of these conditions will result in a complicated and in a large and hence complicated code base for the maintainers to understand. And this brings me to my second point. These are not Nuxt problems. You could face them no matter what was your framework or your choice. Some of the solutions, of course, depend on your framework, like state management, routing, etc. So additionally, the framework, the ecosystem, and the community around it should help you by taking some decisions for you. So what is our goal? Every project has a learning curve. Our goal is to minimize this learning curve and make everything easier to understand for newcomers and everyone in general. And how do we accomplish this? The answer is standards. Establishing a common way of doing things, following design patterns and best practices will ensure that everyone is on the same page and make code maintainability easier. Nuxt, being very opinionated, helps a lot with this, but it's also have a lot of things out of its scope. So let's start by exploring those standards one by one. First one is routing. Routing is a core functionality of any application. We already mentioned Nuxt file-based routing as one of the Nuxt features. You create a file inside your pages directory, and you get routing working without any effort. But at some point, you will need, you can have nested routes, you can have dynamic routes, you can have dynamic REST routes. But at some point, you will need things like page meta, advanced pattern matching, aliases, or any other advanced Vue feature. Luckily, the router is available under the package Nuxt router. you can install this package and have full control over how do you declare your routes. You can have a hybrid approach that both of them work in file-based routing and custom routing, but this caused a lot of confusion for us, so we opted only to declare routes by ourselves and have full control over them. And you can also use router extend routes configuration in your Nuxt config like this. Of course, declaring your routes in the Nuxt config is not the best idea. This will become bloated very, very soon. But luckily, Nuxt modules have access to this config, and we will explore a bit later how we can use this inside, move this inside a Nuxt module, and keep everything related to that module inside it. It's very important to get the routing right. It's very hard to change your URL structure later, and it will hurt your SEO if you do. Additionally, Nuxt does many optimizations, with the page component being your entry point of each chunk. So your pages will affect your bundle size and your overall performance of your application. And next is data fetching. There are several ways to fetch data in a Nuxt application. On top of using the traditional Vue.js hooks like mounted, there are additional lifecycle events that leverage Nuxt's ability to load data during server-side rendering. This allows your page to render with all of its required data available, which improves performance and overall user experience. The problem with multiple ways to fetch data is that the difference might cause a bit of confusion. But don't worry, we will explain everything right now. Let's get this out of the way first. Fetching data during component installation is still available. While using the mounting hook, let's say, the data are fetched on the client and the page load is not blocked. This is useful for non-essential data. It does not affect server response time at all. But this is not recommended. There are better ways. There are two Nuxt lifecycle hooks that can take advantage of Framework's ability to fetch data during server side. The first one is async data. This is a special Nuxt lifecycle hook available only in page component. It will be triggered during server-side rendering before the component instance is created, and on the client when navigating. Navigation until the API call is fulfilled will be blocked. It has access to the Nuxt context, which also contains the store instance, but not the component instance itself. You can use this inside it. The return value of this function will be shallow merged with the component data, as you can see in this image. And there is also the fetch hook, and this is where the things get a bit complicated. Because after Nuxt version 2.12, there are actually two fetch hooks, the legacy and the new. The old fetch hook work much like async data does. The main difference between them is that the fetch runs after component initialization, which means that it has access to the component instance. Another difference is that the fetch hook is not blocking route navigation, and the loading state needs to be handled by the page component itself. This legacy fetch is available for backwards compatibility when a context argument is passed to it. Both async data and legacy fetch have access to the store and can only be placed in the page component itself. And the new updated fetch hook is another way to make API calls during server-side rendering. When called during page navigation or client-side rendering, it is not blocking and it exposes the $sign fetch state at the component level for rendering loading states and errors. Another big difference is that it can be placed at any component of a page, not only at the page level. And if multiple fetch hooks exist on the same page, they will be called in parallel. The anatomy of the fetch state, $sign fetch state is a pending property, which is used, it's a Boolean that is used for loading states, an error that can be either null or the error caused by the fetch hook invocation, and a timestamp that since the last fetch, which can be used for caching things with the keep alive functionality. Additionally, you can pass some parameters. Fetch on server, when set in false, the fetch will only be called in the client side, behaving exactly like mounting hook would be. That's why I told you earlier that fetching data on the mounting hook doesn't make much sense. You can use this. And fetch delay. If you want your call to be delayed, I don't know why. Maybe you want your site to be slower. I don't have a use case about that. I know it's a bit confusing, but I hope this table clears everything up. So which one shall we use? Probably not the legacy fetch. It's there for backwards compatibility, and you should probably avoid using it. Between async data and new fetch, in my opinion, the decisive factor is if you can provide some kind of placeholders or not. If you can, go with fetch. If you cannot, go with async data. If you use the fetch without placeholders, you will hurt your CLS. You will call cumulative layout shift that both talks before mentioned, and you will hurt your performance. Two more ways to fetch data are middlewares. Middlewares run before rendering either a page or a layout. They also accept the context as an argument, which means they can make API calls. But there is a catch. The middlewares run in sequence, not in parallel. So if you have API calls inside them, the calls will not be in parallel. So this is actually an anti-pattern, and you should avoid it. And the last hook is the Nuxt server init. This is a special hook that runs once during server-side initialization. This is a good place to fetch data that needs to be available during the whole application, like configuration, feature toggles, authentication info, etc. The next challenge is that we fetch some data. How do we store them? I'm surprised that we didn't have a talk about state management today, even though Maya at the beginning talked about it a bit. Of course, in a large application, you need a centralized place to store your state. And until recently, the answer to this question was straightforward. Vuex. You added Vuex, you had a predictable way to manage your state, DevTools support for easy debugging and time travel, and a modular architecture with plugins and namespacings. And you still can use Vuex. It's not going away. Vuex version 4 supports Nuxt 3 and Vue 3. But the new cool kid is, of course, Pinia. First of all, the logo is cuter, as you can see. It was enabled and inspired by the new composition API architecture. It looks a bit different than Vuex, but after working with composition API, the Pinia way just makes sense. And this is us the past few months. This is how a Pinia store looks like. The only magical thing is actually the define store helper that is used to make everything reactive. Other than that, you have your state like Vuex. You have your actions to manipulate the state. You could have some getters in order to transform or combine some states, but you don't have mutations, and this is a big difference, and I think this reduces a lot of boilerplate. And this is how you would use it. Very simplified example. You just import it and use it like a hook and directly access state and actions. I think this is much, much cleaner. That's why I'm very excited about composition API and Pinia in general. I have written an article with more in-depth details on this. There are some things like setup stores that are very, very, I think you will love them, and they reduce boilerplate even more. And another topic is modularization. At some point, the application will grow big, and some kind of modularization will be needed. The default structure of a Nuxt project is like this. It follows the folder by type convention, and it's actually okay for small projects. But when you start having hundreds of components, locating what you want will be difficult. A different approach is a folder by feature structure like this. It is inspired by domain-driven design, and it groups all feature-related files together. If everything related to a certain feature is one place, it's easy to understand how it works, and there is a smaller risk of overlooking some parts. It's equally easy to fully remove a feature because you will not forget something because everything is in that folder. I have seen this approach working on a Vue project, and it was fine, but you have some problems about the page components and the routing declarations that can be inside that folder. But in Nuxt, we can solve this with a feature conveniently called Nuxt modules. You can declare a Nuxt module like this. A module is just a function. Inside it, you can have access to the Nuxt config and runtime configuration. You can use things like the register root helper that we saw earlier and move it here and keep everything module related and close in that specific file. And when you reach your point with your module being autonomous and self-contained, you can publish it as an NPM package for everyone to use, or in a private NPM registry, which is what we're actually doing in Glovo, that I'm working on. This is one of the ways to break your app into multiple independent entities, which leads me to my next topic, which is micro-frontends. The definition of micro-frontends is the following: an architectural style where independently deliverable front-end applications are composed into a greater whole, or, as some people call them, microservices for front-end, which is not completely accurate from the implementation side of things, but it makes some sense if you think about code independence and isolation. The idea existed many years, but recently we found this fancy term because microservices also have a lot of abstractions in the backend. And it's time for a poll. Please raise your hand if you have heard about microfrontends in the past, obviously. And who is not working with microfrontends, but it's a technology that he would like to work in the future? Okay. And lastly, who is working with microfrontends and having a good time? Yeah, okay. 5 out of the same as you. This is more aligned with my observations. There is a lot of buzz around microfrontends, but people that are working with them, including us, are not very happy with them. They are causing a lot of problems that we need to solve. Some of these problems are communication between microfrontends, state management, code duplication, UI consistencies, and everything that you see here. So what is the biggest benefit of microfrontends? Your code is isolated. It doesn't affect or get affected from other pieces of code. And what is the biggest problem of microfrontends? Your code is isolated. It doesn't affect or get affected by other pieces of code. There is only one excuse to use a microfrontend architecture, and this is when your app is too big, it's large scale, and you can't do anything else. The idea is to split the product into smaller, simpler applications that can be delivered all the way to production by dependent, autonomous teams working on decoupled code bases. This will also enable us to independent deployments and incremental updates. You will see in the next talk from Dani that migrations are not the easy part. And having a modularized architecture like this, you can upgrade things little by little. There are many ways to implement them. Iframes is what we used in my previous job, and server-side compilation is what we use in Glovo. Module federation is probably the coolest thing right now. And there is also a proposal about portals, which is something like iframe. Don't quote me on this, but it's something like iframe. Sandboxes, you create sandboxes with some specific lifecycle hooks. This is what I got from it. There is this site, microfrontends.com, that has a lot of info if you want to learn more. And it has a good article as well, and a demo. This demo is this application, basically. It's split into multiple microfrontends. Each of microfrontend is a different repo, and it uses different techniques to stitch everything together. Demo.microfrontends.com if you want to learn more. So shipping good, small, maintainable, clean code is hard. Microfrontends help, but they aren't a silver bullet. Big caution when using them. Next section are feature toggles, or feature flags, feature switches, release toggles. They come with many names. They are a development tool that allows us to change the runtime configuration of our application without deployments. Again, there are multiple ways to implement them. At Glovo, we have a custom implementation. At the admin, you create a feature toggle which is saved in the database. This is usually a Boolean, but it can also be a number or a string. And then on Nuxt server init, we dispatch an API call that fetches those toggles and saves them in the store for everyone to have access. You see how everything comes together little by little. Feature toggles can be used to decouple feature rollout for code deployment. Given a big feature, you can create a big feature branch, and when you try to merge it to master, we will have a million conflicts. Or you can create small, independent, unfinished work branches and merge them behind the feature toggle. When everything is ready, you just enable the feature toggle. This will make the life of code reviewers easier as well. Kill switches. If you see something is off with your feature, you just turn your feature toggle off without redeployment, rollback, or reverts. Targeted releases, you can enable a feature toggle only for a specific user, only for me, only for people working for Glovo, or for a specific area, only for Italy, let's say, or only for beta testers, to test only for that part of the users. And lastly, our experimentation platform uses feature toggles internally. And some things to be aware of. Spaghetti and duplicate code, especially for A/B tests. Whatever your code complexity is, a feature toggle doubles it, or even exponentially increases it. Sometimes it's just a branch in your component, but sometimes the whole page needs to be changed, the whole behavior needs to be changed. And some code duplication can be avoided. And when you have duplicate code, you will have bugs. This is where they normally hide. Having a feature toggle as a kill switch is always a good safety measure, but you need to ensure that both states work as expected. Unit tests, automation tests in general, need to mock feature toggles and test both states. I'm going to repeat this. Automation test, unit and end-to-end tests, or every other test that you have, needs to mock feature toggles and test both states that work fine. And lastly, clean up. Feature toggles introduce a lot of complexity, that's why they should be short-lived. You should have a plan to clean the code as soon as possible, and you should make sure that you don't leave any leftovers behind. Regardless of the added complexity, feature toggles are an invaluable tool, and I highly recommend to use it in your workflow if you haven't already. Next section is testing. I've been told that I need to show this pyramid in order to talk about testing. It's something in terms of conditions, and they don't know. But I will not try to convince you to write tests. I think we all agree nowadays that a good suite gives you confidence to merge often without breaking anything. And you need to run them in your pipeline. But I will talk to you about some special kind of tests we have in Glovo. And these are visual tests, mutation tests, and contract tests. The concept of visual test is pretty simple. As you can see this image. If it works, it works. You can take a screenshot from master and one from your branch, and you compare them. If they match, all good. If they don't match, you need to manually approve them. We're using Applitools, by the way, which uses Cypress behind the scenes, which means we can interact with the page. You can ignore parts of the page with selectors. And like Git, because you approve changes, you can have conflicts, and you need to resolve them. Unfortunately, this can't be fully automated. You need a human eye to determine if the change is good or not. But maybe someday with some AI, this will be fully automated. Next is mutation test. The idea behind mutation test is that the code should have one and only one reason to change. So a mutation test tests your lovely pure functions and changes little things inside them. If the test passes, then it changes more until the original function is not recognizable. If the test still passes, it is considered weak and needs to be revisited. If not, the mutation is killed, and the test is considered a good one. There is a lot of hype around mutation tests lately. I have seen a lot of talks in different conferences. I'm not the biggest fan, to be honest, but they are impressive nevertheless. And there are some very passionate people in the company, so I hope they are not watching. And contract test. This is a kind of integration test. They ensure that the API gateway behaves in a predictable way. You define a contract for the API response, and if something changes, the test will fail. This was a big problem for us because we have multiple consumers, web, Android, and iOS, and every change affected everyone. We solved this by contract tests and a BFF. A typical example without a BFF, backend from frontend, looks like this. Multiple consumers use a common API to get data from multiple services or even a monolith. This creates the problem that is commonly referred to as the gorilla banana problem. One of the clients asks for a banana and gets back the gorilla holding a banana and the whole jungle with it. Because the same API needs to serve all the clients, and this client has different needs. To avoid this, instead of having a single point of entry, we can introduce multiple gateways. This way, you can have a tailored API that targets the needs of each client. This will enable us to remove a lot of bloat and deliver features faster. There is one obvious problem. What about the common code? You might be tempted to abstract this logic to a common reusable endpoint, but you will soon face the same issues as before, with everything becoming rigid and hard to maintain. First of all, having some duplication might be okay. Even if you didn't have dedicated gateway, this logic will be in the client, and them having different languages is often hard to spot. But if you are strongly against code duplication, which you should, by the way, you can create new services that aggregate data from other services and everyone uses. Okay, next section is UI UX. It's not our job to work with Figma, but it is our responsibility to have a consistent user experience and user interface across our website or even across different websites. And this is very hard to do, especially when everything is modularized and independent. We need to establish some rules, and we need to make sure that these rules are respected. Of course, variables for color, spacing, font sizes, etc. should be abstracted in a centralized file for everyone to use, but this is not enough. One way to approach this is a component library, either a popular one like Bootstrap, Material UI, or Chakra UI that we saw earlier, that you need to set up according to your style guide, or a custom one that you create from scratch. This way, you can ensure that common components like modals, buttons, dropdown, etc. are consistent across all your applications. Full disclosure, my personal experience with third-party libraries, it was not the best. We had a lot of memory issues, a lot of performance issues, and migration nowadays, it's holding back from this in a lot of code bases. So if you have the resources, my strong recommendation is to go for a custom one. And the component library can be part of something bigger like a design system. A design system is a collection of components, documents, articles, examples, code snippets, screenshots, design guidelines, philosophies, and other digital assets of a company. It's the source of all truth, a reference to ensure that everyone who works on their project is always on the same page. The design system of Glovo, it's called Helio. It is a component library. These components are available for every client, for web, for iOS, for Android. Everyone, we have implemented for everyone. But it's also a guideline for accessibility, animation, voice and tone, and everything that we saw in the previous slide. I would say that design system is something like a code knowledge base, a wiki on how to create user interfaces. And the last section for today is observability. Good observability is essential for a reliable system. You should be able to measure everything, determine the system health, and trigger alerts if something is off. When something is off, you should be able to diagnose and fix issues when they arise quickly. This is why you need to invest beforehand, not when it's too late. The following question is what to monitor. Of course, the overall health of the system is the first priority. For number of visitors and orders, we can use anomaly monitors like this screenshot that take into account the seasonality of the data. And error monitors. This error should fire alert probably, and someone should fix it. Flame charts. You can monitor a specific request with high details and know exactly where every millisecond was spent, which function, which API call, etc. Custom metrics, very useful for better custom debugging. And heat maps and recordings. We are using Hotjar, and it's always very interesting to see how the users are actually using our application, not the way we imagine. And performance and web vitals that we also saw before, and I want to expand a bit as well. Performance and Nuxt might seem related, but the solution to main performance issues is actually often Nuxt. A fast website performs better. There are multiple case studies behind this, and I can confirm this from my experience in Glovo. Additionally to losing users from the slow website, Google recently started promoting websites with good performance in the search results ranking. More specifically, Google uses 3 metrics to determine who will be promoted. These are LCP, FID, and CLS. LCP refers to the time it takes for the biggest element in the page to appear. This element can be a text, an image, or an iframe. And because the viewport of each device changes, maybe your LCP is different in each device. To improve your LCP, of course, server-side rendering helps, but it's not always enough. First, you need to identify it and ensure that it's not lazy loaded. Even better, if it's an image, preload it, use the right format and the right size, as Alba said before, and everything else that Alba said before. Another note that is, even if you optimize something and another bigger element comes after in your page, a modal or a cookie banner, let's say, this will become your LCP, so be aware of these use cases. The second is FID. It refers to the time between the load of the website and the time the page is interactive. JavaScript and CSS evaluation are error blocking and will affect these metrics, so be aware of what you load. And the third metric is CLS. It refers to the shifts that are caused by lazy loaded components or images. You need to lazy load as much as you can for your initial page load to be good, but without causing CLS. You need to find a balance between these two. These 3 metrics are called core web vitals and will improve your user experience and significantly affect your rankings and your conversion, which in a big company means a lot of money. I'm going to leave you with some resources. All of these are very popular books, so probably you have read them already. If you haven't, I highly recommend you do. Unfortunately, we don't have that many Nuxt-related resources, but hopefully until vueday 2023, this will change. And the key takeaways from today are, Nuxt is awesome. It does way more than server-side rendering. It's built around good standards and best practices. Use it to your advantage. Pick the right fetching strategy between async data and fetch. Use a centralized state management library like Pinia or Vuex. Modularize. At some point, your application will be too big and you need to break things up. Use Nuxt module to make everything independent. And if your app is still too big, consider micro-frontends, but be aware of the problems that they will introduce. Use feature toggles as kill switches and to keep your pull requests small. Use a design system to maintain consistency and save time in the long run. Automation tests are essential. Have a good suite and coverage and run them in your pipeline. Observability is essential. Measure everything. And have performance in mind. A fast website performs better. Of course, there are more things to consider, and any of these things could be its own talk. But I hope you learned something useful today. Grazie. I have 4 minutes for questions, if you have any. I know we didn't get into much depth, but and I will be around until the end of the day.
No questions? I do have two, actually.
Oh, no.
So, first of all, you mentioned Nuxt 3.
Yes.
What are the most exciting parts for you around that?
There are a lot of exciting parts, some composition API, first of all, but we can use that actually use. Should I turn this off first? We have some projects that use Nuxt 3 and everyone wants to move to that project. So they are doing something good, probably. But yes, I would say Pinia and composition API, the new way of doing things is much, much clearer in my opinion.
Okay, and thank you for the answer. And you mentioned centralized state management, and you talked about Pinia and Vuex. And what are your thoughts on integrating GraphQL and Nuxt?
You should do that. It will make things much simpler and cleaner. We consider doing this in our BFF. We haven't explored that yet. But yes, it's very excited. It's something that we want to do at some point. But I don't. It's one of the things that I wanted to explore, but not yet.
Thank you very much. Let's give Fotis another round of applause.
Thank you.